Oh, okay, everyone. We can come back and okay. I think there are a lot of good materials on the YouTube, and their pictures, their explanation is much better than the textbook and my explanation. So I use them because they are free resources online, and I just play the video. You can find the link here. You can find the link here. And now we can practice the part as we told the last week, and about examples from 9.2 and 9.3 about the t-test. Then we will go back to the normal distribution. I know the teaching sequence is different because we need to learn the probability theories, then go to the normal distribution, then go to the t-test, then go to the p-value. But I know I try to flip the sequence. I plan to reverse the sequence. Then I think it's a trial for me. I can test them. If in the future it works, I will teach next year with the same way. So now we can go to our textbook here, 9.3. Okay, and I think 9.3 is better here. Okay. Okay, and here, this section will look at how analyze when two samples are collected and whether they are dependent. What does it mean, dependent? Sometimes we can say they are different. If we say they are different, that's easier to understand. As with all the hypothesis tests and confidence intervals, here when I was a PhD student, I really had the hypothesis test because we need to set the non-hypothesis. We test then we can reject or we accept the non-hypothesis. Actually, I don't like it. So I ignore this part. And I just switch to the p-value, and you can read a lot of story. But I believe in the future, after you become familiar with this part, you can read those hypothesis tests by your own. Okay, then we can see. And confidence intervals, the process is the same through the formulas, and assumptions are different, and the differences between the independent t-test as opposite to the other tests that you have been done. Then there are actually two different formula to use depending on the particular assumption is made or not. And here hypothesis test for independent t-test, two sample tests. And actually I like the video previously because let me show the video here. Oh, not here. Not this one. Oh, it's an advertisement. Let me skip it. Okay, let me review this part. Okay, then last week I explained by this video, and I said there are three types of t-test. The first one sample t-test, the basic assumption is you already know the population, the standard deviation and mean in the population. And here the diagram is an earth, in an earth, and 5 people here are the samples. If you want to test whether the group of sample are from the big population, you can conduct one sample test, t-test. And the second independent samples of t-test, for example, from the left group, 5 people, from the right group, 5 people here, and the dashed line here, it means the average, the mean of it. We can see from the left dashed line is a little bit higher than the right one, but we cannot say they are different because we need to calculate the standard deviation with the formula t-test. Then later I will show you how to run the independent sample t-test, especially for 2. If you have more than 2 groups, 3, 4, 5, 6, 7, 8, you can run one way or 2 way ANOVA. That's different. And the third one is paired sample t-test. Paired t-test, it means the same people, for example, $1 and a group of people, we drink oolong tea. Before we drink, we check our blood pressure. After we drink for 1 month, we check our blood pressure. Then, because we are, for example, John, Mary, Samuel, and Melissa, a lot of people joined the trial, and before they drink a oolong tea, after they drink, they can check the blood pressure. And this kind we use parity test. And next week, I show you how to run those tests. And today, we review this part. We use the examples from the textbook. That is part 2, chapter 9.3, independent samples of t-test. Okay. Then go to the textbook. Textbook 9.3, independent samples of two means. And those hypotheses are, I will skip this part because it's very boring. It's very boring. But when we do the example questions, I think you can understand more. Okay. Here, the samples do not need to be the same size, but the test is more robust if they are. Okay, if the number very close, there is better. That is better. And 2 samples are independent. Population 1 is normally distributed. Population 2 is normally distributed. Just as before, that is okay. Then here the t-value, t-score here, and let me tell you, that is really ugly. And let me skip this part. I will tell you how to use the online application or your apps on your cell phone to do this part. Later, you can get the answer very quickly. And wow, see, the formula is ugly. And this one is ugly. And non-hypothesis, here. If the mean 1 minus mean 2 less than 0, that's this one larger than 0, not equal to 0, like this. No, I will skip this part. Okay, then the second concept is the confidence interval of the difference in mean from 2 independent samples. Okay, I will skip this part. And this equation is really ugly. If you have chance, close to the end of semester, I will tell you how to do this. But again, the concept is not easy. The calculation by the online application is super easy. And the formula are very ugly. You don't need to do that. And we just test the examples with our software. Okay. Then here, example 9.3.1, hypothesis test for 2 means. And here, the cholesterol level of patients who had a heart attack was measured 2 days after the heart attack. the researchers want to see if the patients who have heart attacks have higher cholesterol level over healthy people. So they also measure the cholesterol level of healthy adults who show no signs of heart disease. Okay, then the group 1, group 2, they are 2 groups, significantly, obviously. So I prevent to say the term. Obviously, they are different. And now, from this example, the author want to compare those differences. The result is in table 9.3.1 cholesterol level from the year of 2013. Data show how people have the heart attack and tested at the 1% level. Here is the condition given by the author. Okay, and now we can take a look at this cholesterol level of heart attack patients here. Here. Okay, and I don't know how much patients in the first group, because here, cholesterol level of heart attack patients, and the group 2 is healthy individual, healthy adults. I don't know the number, but 2 more than the patient group. Okay, now let me tell you how to do this. First, go to your, let me have this. Go to the go to the online, your Google Drive. Here is my Google Drive, and create a Google spreadsheet. Here, the date is 2024 May 15th. The independent T should be in lowercase t test from chapter 9.3.1. Okay, and now I go to the textbook here. I copy, paste everything from the table. Copy and paste it. Okay, get it? Then you can do this part. Then you have 2 choices. The first one, you did the calculation by yourself. For example, okay. Let me have it here. I use the yellow background, and here I use green background. Okay, and now here I try to calculate mean. And I calculate sample deviation. Okay, mean, again, let me review how to calculate. Plus and equal and average, and the range is from here to here, and enter. Oh, what's wrong with it? Oh, okay. The average is here, okay? And you don't need to repeat. Okay. Here again, the second group, the normal, the healthy individuals, click equal and click average parentheses and the range from here, and I hold the shift key and the left click on the mouse, okay, and that's correct, and answer. And here, so far we can see the average from the patient about the blood cholesterol. The cholesterol level is 253, close to 54. The other group is 193. Can you say they are different? No, you cannot judge that just by the average. You cannot judge it. You can say, okay, the average here is higher than the other group. You can say this, but you cannot say they are different unless you get the standard deviation. Okay, then now let me run the standard deviation. Okay, again, here you can insert, I think I should set the language label to 1 minute please. Let me set the label, the language interface to English. One minute please. The language. The language, where's the language? Oh, come on, where's the language? Okay, I got it. Okay, and here's the language setting. I set English in UK because the unit is in metric, not in inch. Okay, I get it. Okay, now it's in British English here. Okay, and now I want to know the standard deviation here, and I can select the range here and select, sorry, here. I click the cell here and insert. Where's the function? Insert function, go to the SSS statistical standard deviation, STDEV here. Standard deviation S is for samples. Okay, again, what's the difference between the samples and population? Just a reminder again, when we select standard deviation, P population in the denominator, again, in the denominator, n-1 is for samples. And if your population, you don't need to -1, you just use n, that's population. Okay, again, so this part, sure, in a big view, in a big frame, you cannot observe the difference because when your sample number is very big, but you need to have the correct concept when you select here the p-value. Okay, sorry, let me do it again. 1 minute please, let me turn on the again. Let me show it again. For the population, for the samples of population samples, okay, and the standard deviation of it, that's a square root in the denominator, that is n in the numerator, that is sigma hypothesis xi minus x bar, and take the square of it. About the samples, square root, the same in the denominator, sorry, the same in numerator, sigma, the sum of xi minus x bar square, but here is different. It becomes n minus 1 because the degree of freedom should. Oh, come on. Okay, is this part? Okay. Again. For the population, from the equation, the denominator is n. N is for total number of the population. It's very big number. Okay, then for sample, that is n minus 1. I think, don't ask me why, because the theory is really hard. I cannot understand. I read this many times. I don't know why. I admit that myself. I don't know this is the reason. But we just need to know how to operate it, how to calculate. That's enough. Because believe me, the theory why the denominator should be minus 1, I don't know because the theory very hard. I read the articles in English, in Mandarin, I cannot understand. But for calculation, very easy. Population n, sample n minus 1. But this part, take a look at this. Insert function statistical. Sorry. As here, you can select this one, either this one or that one is okay. Standard deviation P, population, or samples. Okay, again, my question is, how can you know those heart attack patients, they are samples or they are populations? Okay, let me ask you again. Do you think the sample number here? My question is, cholesterol level of heart attack patients, there are maybe 20, maybe 30. My question is, do you think they are samples or they are populations? The second group, cholesterol level of healthy individual, do you think they are samples or they are populations? If you are the host, you make the definition. You don't need to follow the definition. But the definition, the sample is from the textbook. So we try to think about the original meaning from the author. Here, cholesterol level of heart attack patients, I think they are samples, they are not a population, because with limited number of patients, they try to use this number to calculate the heart attack patient all over the world. Okay, and this one about the healthy adults, their cholesterol level, they plan to use a small number of this number. Then they want to represent whole healthy individuals, their cholesterol level. So both of them should be in samples. Now we use the Google spreadsheet to calculate this part. Again, insert the function and go to the statistical and go to the sample standard deviation of sample. So you can see a small s for samples here, a p for population. Okay, so we select this function and click. Then the mouse is between a pair of parentheses. Then select the range. Hold the mouse key from B4 to B31. That is correct, and click answer. Okay, that is 47. And here you can do that again. Or we have an easy way. See, there is a small dot, round dot here. Click it and drag to the right. Done. Okay, please use 1 minute to finish this part. If you finish this part, you can go to the website here. Either one is okay. Either one is okay. I prefer to use OpenAPI. Click Open API. I highly recommend you to use this. T-test. You can go T-test and enter the sample size, mean, and standard deviation. Okay, 2 minutes, you can do this part. Okay, let me show you how to do this. Okay, then here, you can set different confidence interval, but the 95, in other words, the p-value is setting at, the p-value criterion is setting at 0.05. Okay, the first group, the group number is 28. The mean, okay, very close, okay, maybe 253.9. Okay, the standard deviation 47.7. Okay, the second group, the number is 30, and the label is 193.1, and the standard deviation 22.8. Then, okay, then click calculate. Okay, from the calculation after here, we can see the p-value is here. Wow! Can you see it? P-value is 0.0001788. That is very small, smaller than 0.05. Thus, we can see those two groups are different. Those two groups are different. Okay, let me show you what does it mean. It means well, okay, I got it here. What does it mean? It means according to the current information, after the scientific calculation, we can say the cholesterol level from 28 patients 2 days after heart attack, their cholesterol level is significantly higher than the healthy adults. Is it okay? Again, the calculation is very easy, super easy. You can do it, but the formula really ugly. But you will see more ugly than in other tests about F-test and chi-square and one-way ANOVA. Again, that's nightmare. Again, calculation is easy, like what I teach you how to do. But the principles and the formula really, really ugly. You don't need to understand the details. But just remember, two independence tests, after the calculation, the bell is ringing now, and after we conduct the t-test for this group and this group with the cholesterol level, we can say they are different because the p-value is very small. It's 0.0001, very, very small, far away from 0.05. They are different. What does it mean? It means if, they designed these experiments just one purpose. If I check my cholesterol level, okay, I will check it. Okay, and if your cholesterol is very high, it could be, it could be increase your risk to get a heart attack. Can you get it? So after those tests, it's a strong evidence, but I cannot say, as long as your cholesterol level close to this high, you will get heart attack. I cannot say that because in our language, in Mandarin, there is a defect in Mandarin language. But in English, it's very clear. The cholesterol level and the heart attack, that is linked. Again, higher the level of the cholesterol is linked to heart attack, the probability. But in our language, and in Mandarin, I have the idea in your original language. The stupid reporters, stupid media, they always say the higher level of the cholesterol will cause heart attack. Again, it's completely different concept. Again, linked to, relation to, correlated to. It doesn't mean the reason, the cause, and the results. It doesn't mean it. But in our language, so sorry, I don't want to overblame Taiwanese people, but they are not smart. Again, in English, link. The higher level of the cholesterol will link to the heart attack. But maybe heart attack causes the higher level of cholesterol. This is the reason, this is the result. Reverse what you think about it. So again, in the statistics world, we just found a correlation, but you cannot find who is cause, who is result. It's very important, especially for stupid Taiwanese. Sorry, I apologize for using such words, but again, find a correlation. Later, for more research, you can find the reason. What is the real reason cause the problem? Okay, have 10-minute break.